this is Susan Sutton, editor of ASI. I'm here at the ASC Spring 2015 Convention and Expo in Nashville, Tennessee, speaking with Rajesh, who's the technology group leader with Eastman Chemical. Rajesh, thanks for joining us.
Good morning, Susan. How are you?
I'm well, thank you. We're going to be talking about polyolefin-based adhesives and what makes olefin-based adhesives technology attractive to formulators.
So mainly for formulators or even in a brand owner standpoint, right, the current swing, most of the adhesives technology that exists within pressure sensitives and the hygiene and the packaging segments are styrenic blockopolymers or EVA-based chemistries. So in the last several years, there has been some fluctuations with availability and price. So one of the reasons to switch to olefins is supply security, to reduce this volatility in availability and price. That's one of the advantages to switch to olefin or the drivers. The second is what olefin chemistry brings in is the thermal stability characteristics and also clean runnability in machines. So that also provides the second advantages of being clear, transparent, clean adhesives compared to the traditional styrenic blockopolymers or EVA-based adhesives. So the thermal stability and higher stability characteristics turns into clean runnability, faster speeds also. So that's the second advantage. And the third advantage is probably what we call it as a density differences. So probably is mass per volume. So you may be able to use a little bit of density advantage in certain cases with certain olefins. So that's the third advantage. And why switch to olefins will be mainly because if you think about the North American cracker slate dynamics, more and more lighter cracking is happening in the North American region and also in Europe. So as we go towards more and more lighter cracking, that means more ethylene, propylene, and olefinic derivatives are available, while the higher cracking slates such as butadiene, isoprene, etc. are becoming less, means availability becomes an issue. So that's another reason why people also want to move towards the olefins to, again, coming back to supply security reasons.
Okay, thanks. What are some recent developments in polyolefins?
So recently there has been, if you look at the polyolefins has been there previously, if you even look in the pressure sensitive adhesive industry, so in around 70s there has been olefin-based chemistries available for hygiene market. But then after the styrenic blockopolymers, it took over the market and an EVA became more popular in the packaging, and styrenic blockopolymer became more popular towards the pressure sensitive adhesives and the hygienes. But in 1990s, there was some recent discovery on catalyst technology. So which was most of the olefin development has been driven through the catalyst technology, which made more metallocene-based catalysts provided a little bit more control over molecular weight, branching, controlling molecular architecture, even using lighter cracking slates. So that provided the polymers, or that enabled the olefinic polymers to perform more closer to the traditional levels of styrenic blockopolymers or EVA polymers, which is highly used in pressure sensitives and the packaging industry. And from that onwards, there has been several advances within the catalyst technology, metallocene, ethylene-based, and the propylene-based. And that provided the formulators one more tool in their toolbox without sacrificing much performance. But still what lacks currently is, even though they met the performance, what we call it as the robustness in performance. Once you are applying an adhesive, it has to come through a small nozzle, and it has to be applied to different webs, which can be cardboard or polyethylene, different substrates. And the other thing is the line speeds also affect. So polyolefins has a narrow window of robustness when we call it formulation flexibility, application temperatures, applying it into different substrates. All this encompassed within that robustness window. So that's one of the limitations of current olefins. But still, olefins are capturing the markets within pressure sensitives and the packaging segments. So there is more development happening within this olefins to increase that robustness, to improve the sprayability characteristics, application window, improve and applying it into different substrates so that it will cover most of the performance attributes or the robustness window of the current existing styrenic blockopolymers or the EVAs. And that's one of the reasons why we came up with this new polymer amorphous polymer, Polyolefin-based olefinic chemistry, this novel technology. It's a unique catalysis and processing technology that we came up with that improves the robustness window of the olefinics. That is not current, means that with current existing olefins, with the robustness window which is narrow. But with the new olefin technology, it increases the robustness window in a way that it is applicable at a low, it has a broader application window from low temperature as low as 120 to up to 160 for hygienic applications. So, and also it performs differently. And the adhesion performance is also very good on the final application standpoint. So that mainly for the robustness, that's where most of the people are concentrated. And we are very excited and happy that we were the first one to introduce this into the market with a broad, robust operating window olefinic solution that can really compete with the current technologies out there.
Sounds great. Thank you.
Thank you very much, Susan.